Hello, thanks for joining. I'll just give it another minute. I give time for people to join. Thanks for joining. I'm just going to give it another minute, allow time for people to join. Can everyone see my screen? Okay. I will get started. If you have any questions at any time, please feel free to unmute and interrupt. I prefer live questions, but you can also drop them in the chat and I will try to monitor that as well. Okay, let's get started. So thank you for joining this webinar for BD Research Cloud. I encourage, if you haven't already created an account, to go ahead and do so you can click and follow along. In order to create a free account, you just need to go to bdresearchcloud.com. And this is the login that you'll see if you use FlowJo portal already. So that's where you use an email and password to access FlowJo. You would use the same login for BD Research Cloud. But if you don't have a portal account, if you use a dongle or a serial license number, you can always use create account. And even if you don't use FlowJo, just press the create account button, and that will allow you to create an email and login to access BD Research Cloud. All right. So for today, we're first going to start with an overview of what is BD Research Cloud. I'll go through the internal structure, how groups and projects help you stay organized and limit access to different data for different people. And then the highlights of what's new in version 6 that just came out. And then I'll go into the live demo. So what is BD Research Cloud? It is a suite of online tools designed to streamline and improve the entire flow cytometry workflow. So this was specifically designed with flow cytometrists in mind. So within BD Research Cloud, you can upload, save, and share cytometer configurations. These can be BD or non-BD instruments. You can create panels using reagents from the BD catalog, or you can create custom reagents using fluorochromes from a variety of vendors. You can manage your reagent inventory, so know which reagents you currently have in your lab, track their titrations, and then easily create some staining sheets for your panel using those reagents from your inventory and their known titration. You can also choose to create experimental workflows or cytometer maintenance log with workflows to keep track of who did what and when in the lab. So when someone performs a task, it's captured with a timestamp of who did it and at what time. You can also create FACSDiva experiments directly in BD Research Cloud so that you don't have to wait for your turn to hop on the cytometer to set up your experiment ahead of time. So when it is your turn to go to the cytometer, you're ready to go and you already set it up through BD Research Cloud. Within the FACSDiva experiments, you can also easily copy and paste large amounts of information. We recommend this for keywords to include specimen information. And there's also, you can create your plots and gating hierarchy within BD Research Cloud, and you can also add N by N plots with one click, making it much faster. And lastly, there's a file storage component where you can upload, organize, and share your data directly in BD Research Cloud. And this has connectivity with FlowJo built in, no plugins necessary, so that you can perform your analysis in FlowJo from any computer. Let's go through the structure of BD Research Cloud. When you first log in for the very first time, you're given an individual organization. That's for you to use, and you cannot invite other people to your private organization. You can then choose to create a collaborative organization for your lab where you can invite different users to join this organization. Within BD Research Cloud, a group represents users working together on one or more projects. So within a BDRC organization, you can choose to create one or more groups, and then you can put users in different groups. Projects are found within groups, and they contain all the relevant files of that group. Any user that belongs to the group will have access to data, all the data that's related to the projects within that group. However, if they're not, then even though they might belong to the org, they won't have access to that data. So that's one way to determine who has access to what. So when you do invite your user to your BDRC organization, you must assign them to a group. A user can belong to more than one group, and there are no limits on the number of groups within an organization. So groups and projects help you organize your data and determines who has access to it. How you choose to organize your groups is up to you. You can either have a BDRC organization for your institution and then have the groups be different labs and departments. Or alternatively, you can have them be smaller. So one BDRC organization for your lab, and you can have either just one common group that everyone has access to everything, or you can add multiple groups if you need that separation, if you're working with a collaborator, for example, and you only want them to have access to a portion of the data, maybe not all of it. When you add a cytometer to your BDRC organization, everybody within all groups will have access to that cytometer to create panels or to create FACSDiva experiment templates. If you want other organizations, so other BDRC organizations to have access to your cytometer configuration, you can choose to do so. You can either keep it private and then it stays within your organization, or you can choose to make it public and then anyone can link to your cytometer. So when someone links to your cytometer, all they have access to is the configuration information. They can't edit it, they can't modify it. So you still retain control of that cytometer, but they can use its information to design a panel or create a FACSDiva experiment with that. The advantage here is that if you are a core lab that has many cytometers, you can then choose to make them public, and then anyone else within a BD Research Cloud can connect to your cytometer, and you don't have to invite the users and manage those users yourself. So again, to create an account, just go to BD Research Cloud, add your FlowJo portal credentials here and log in. If you don't have those, just go to create account and follow the instructions there. Once you're logged into BD Research Cloud, this is what you see, the home page with the different sections of what you can do. So in the panel section, you can view panels or create panels. In experiments, this is where you can view or create FACSDiva experiment templates. You can perform workflows or create workflows here, upload your data and organize them in different projects. The cytometer section is where you can connect to other people's cytometers or upload your own. In the reagent section, this is where you would manage your reagent inventory and titration information. Populations, this is where you can define which markers are used to identify different cell populations that are of interest to you in your lab. You can assign antigen density, and then you can use that population information during panel creation. And then lastly, the other two, groups and projects. This is where you manage your different groups, so which users belong to which groups, what projects are within those groups, and then the users, which groups they belong to, and what permissions they have within those groups. Let's see if there are any questions so far. Doesn't look like it. You all have the ability to unmute, so if you want to ask a live question, please go ahead at any time. All right, so if we go to the first section, cytometers. So you can either add your own cytometer or connect to your core lab's instruments. And once you do connect to an instrument, you will have access to its configuration to design panels or to create FACSDiva experiments. A new feature in the latest version of BD Research Cloud is if the cytometer is connected to BD Assurity Link, you can now have access to your QC data from any computer. So this is great, especially for core lab managers, that there's the dashboard tab that you can view at a glance all your cytometers at once and see when it was the last time they ran their QC, their last status. You can view or download the PDFs of their QC runs. You can look at past PDFs and then you can plot the data over time, or you can view the plotted data. You don't have to make these, they're already made for you. Moving on to the panel section, within BD Research Cloud, it comes preloaded with optimized panels. So these are either OMIPs, published peer-reviewed panels, or they also include the panels that were developed internally at BD. They're optimized for BD cytometers. These include the panel blocks, the interactive human cell map panels. Here's an example of a panel block that we have at BD that you have a lymphocyte backbone, and you can choose to stack them with different sub-panels that are all compatible with colors that work all well together. Of course, you can also view your custom panels that you've created internally for your lab. What's great about BD Research Cloud is you can easily search through these panels using multiple antigens. You can also create a panel using another one as base. You can see how well an OMIP or BD panel works for your cytometer configuration, or you can create a brand new panel from scratch using our 5-step panel creation workflow. And I hope to demo that for you later. You can create panels for both traditional or spectral flow cytometry, or if you happen to have the S8 or FACSDiva S8, the BD, the latest flow cytometer that also has an imaging component, you can design imaging spectral flow cytometry panels in there as well. We have tools for specifically for spectral panel design. Here I demonstrate that there's many sources of spread when it comes to a spectral panel design. And one of the sources of this spread is the unmixing itself. So there's the panel design that's related to the antigen density, the reagent selection, spectral overlap, sample prep. There's the instrument itself. But the very active unmixing is also a contributor to spread. And as we all know, panel design, we're always looking to minimize spread in order to maximize resolution. And so within BDRC, we found a way to measure and predict which combination of fluorochromes will lead to the unmixing dependent spread. So here's an example of what that might look like. Here's a single stain that was taken from the OMIP 69. These are single stains of either Spark or Alexa Fluor, and these are unmixed with a matrix of 2. So it's fluorochrome and autofluorescence for that sample. And you can see that when we're unmixing with only 2 parameters, we have nice resolution of these single stains. So Spark NIR has nice resolution. The negative is nice and tight. However, if you take those same single stain samples and unmix them with a much greater matrix, so matrix of 40 parameters, you can see the effect of unmixing dependent spread on these 2 fluorochromes. So the negative population becomes much wider, leading to a loss of resolution. So within BDRC, we have a tool to predict this effect. To predict this effect. And so we have a similarity matrix, which shows you pairwise comparisons of 2 fluorochromes of how similar they are. The more similar they are, the more likely they are to have some spreading. However, the unmixing dependent spread can be measured by the hotspot matrix. So this shows you specifically which combination of fluorochromes within the context of the entire panel will lead to some spreading due to unmixing. As for the reagent component, you can easily upload all your reagents at once with the bulk upload feature if you already have these in some sort of spreadsheet. You can also manually enter them one by one. And if you're using the inventory feature within BDRC, when you're creating a flow cytometry panel, it will show you which one of these reagents you already have in the lab. You can also save titration information for these specific reagents. You can create this concatenated image directly in BDRC by uploading the individual FCS files, and then it'll create this image for you. You can link the documents to your reagent inventory items for easy lookup. And one of my favorite features, there's a scanning functionality that comes with BDRC. So if you use your mobile device and log into BDRC from any browser, you'll have a limited version, and that will allow you to scan reagents. This allows you to add a reagent to your inventory, look up its titration information for a reagent, or add to a wish list for reordering if you've just finished a vial and you need to remember to buy some more. So this is what it looks like on a phone. BD Research Cloud, you press the button here to scan. It'll ask for permission to use your camera. Then the camera will read this 2D barcode, and then it will show up as an item that you've scanned. You can scan multiple reagents and they'll populate a list. If you click on any one of those items, then you get detailed information about that reagent, who scanned it and when, the catalog number, lot, expiration date. So this is great. You don't have to type any of this information in. The scan brings in this information. If you scroll to the bottom, it will show you if it's already in your inventory. So in the case of a new reagent you just purchased, you would scan it and just press add to inventory to easily keep track of it. If it's already in your inventory and you're scanning a reagent that you just pulled out from your refrigerator, you'd scan at the bottom. It'll show you the location, the quantity, and also the titration information that you've entered based on your specific needs. Then you can either update the inventory. If you say you had 2 vials, now you're down to 1, or if you had 1 and now you're down to 0, you can add it to your wish list or remember to buy some more. And then when you're done, you can just delete the scan, and then your scan list will be ready for more entries. Once you've added the titration information to your reagent, a great advantage is when you have a panel in BDRC, you can just tell it to create a staining sheet. All you have to do is tell it which markers you want in which staining step, and it will pull in titration information for you automatically. You tell it how many samples you're planning to stain and the final volume, and it'll create all the calculations for you. So if you have multiple lots in your inventory, you just use the drop down and select which lot you're staining with that day, and then you can export the final sheet or print it out for record keeping. You can also add additional reagents for the staining, such as Brilliant Stain Buffer, Monocyte Block, FC Block, and so on. For the FACSDiva experiment setup, once you've created your panel in BDRC, when it's time to set up the experiment, it's really easy. You just tell it which panel you've stained your sample with and which cytometer you're using, and it'll populate the detector fields for you. So this is faster than manually typing it. It prevents any typos. It also has an easy copy and paste to rename your specimens or add keywords. We always strongly recommend the use of keywords and that you enter this information prior to acquisition. The advantage there is that once you enter the information, it gets saved into the FCS file. So then as you move that FCS file to FlowJo or any other analysis, you'll never lose that information of what sample it was and the conditions and the panel. So this makes it much easier. And again, you can do it from any computer ahead of time while you're waiting for your turn to use the cytometer, even during an incubation. You can also create your hierarchy ahead of time. And we have the easy N by N, so all parameters versus all parameters to check how well your compensation or your unmixing is. And the last piece here was the data upload, groups and projects and users. So you can upload data to a project. That project is within a group. Only users that belong to that group will have access to that data. And then you can dictate permissions of those users, what they're allowed to do, only view it, or if they're allowed to edit it or delete it. When it comes to analysis through FlowJo, BDRC makes it really easy if you're performing analysis on multiple workstations. So in my case, I would sometimes do analysis in the lab or sometimes at home. And it was a bit of a pain to always be moving and shuffling those files around. And I'd end up with multiple copies, and sometimes I didn't have the latest workspace. FlowJo workspace available at work if I forgot to upload it at home. So BDRC solves that issue. It's really nice. All you have to do is upload your FCS files to BD Research Cloud, and then it will manage the files for you. So when it's time for analysis, you open up FlowJo, you say add samples from BD Research Cloud, then FlowJo will connect to your BDRC account. You tell it which files you want to work on, and then BDRC downloads those files for you in the background so that it doesn't affect FlowJo performance. FlowJo really performs best when the files are local and you're not working through a network. So BDRC will download a copy of your FCS files in the background on your local workstation to allow for optimal performance of FlowJo. And then when you're done your session for the day, all you do is you save the workspace, the FlowJo workspace, back to BD Research Cloud. So save workspace to BD Research Cloud. The workspace gets saved back up to the cloud. And then when you go to a different computer, say you're done working from home, you're going into the lab, from the lab, you would just open the workspace from BD Research Cloud. It will open the latest version of the workspace for you and then download a new copy of the FCS files onto that new workstation that you're on. The download of the FCS files happens the very first time you connect if those samples are not yet on your local computer. The second time you return to that computer, it won't download them again. It'll already know what location it put them in, and you can continue your analysis quite quickly. Checking for questions. Doesn't look like there's any questions. So this is what it looks like when you say add samples from BDRC from within FlowJo. You get a new window that pops up. All you have to do is select which organization you want to pull those files from, select the project, and then select the FCS files, and it gets pulled into your workstation. If any of you are using the FACSDiscover S8, you know that in addition to FCS files, there's also a CVW file that gets created. So those are the imaging files. That CVW contains all the images of all the cells that you've collected for that one sample. Within BDRC, you can upload the CVW and perform the extraction. So from that one file, you can extract the individual TIFF file. So the individual files will have those individual cell images, and you can perform that extraction in the cloud. And then when you connect to FlowJo, you would use the CellView Lens plugin to view your imaging data. And CellView Lens uses a smart download feature where it will only download the TIFF images that you're interested in so that you don't have to move those thousands of images around if you're not particularly interested in looking at those cells at that time. So for resources, if you have any questions, comments, or if you want a more in-depth training for your lab, feel free to contact me directly or go through tech support flowjo@bd.com. Webinar, so this webinar, here's the link to it. It is recorded, so you'll have a copy of it. And then there's also previously recorded webinars as well as FlowJo analysis webinars. And at FlowJo University, there's short videos on how to, so how do you create a panel in BDRC? How do you create a FACSDiva experiment? So they're bite-sized, shorter videos that just walk you through specific features. And also within BDRC, we have the tutorials and tech support as well. So let's hop over to the demo. Oh, I see a question in the chat. How can we get the recording? Okay, so the recording is in not FlowJo portal, whoopsies. So FlowJo website. So if you go to flowjo.com, learn webinars, this is where you probably signed up for this webinar. So join. If you keep scrolling, you have recorded webinars. So if you click on this link, then this recording will show up here. And then you can see all other past webinars that FlowJo has done as well. Intro to FlowJo 10, BD Research Cloud, high dimensional workflows. And then you can see we have lots and lots of great webinars that are all recorded and available for you to watch when it is convenient for you. While we're here, so learn webinars is where we went. If you go one more down, learn FlowJo University, BD Research Cloud. This is where you have the short video tutorial. So getting started in BD Research Cloud. So it gives you a quick tour, how to create an account, how to create a shared account. how to define your cytometer, applying a license. And then over here, it shows you how to create populations, create panels, how to create custom reagent, Diva experiments, FlowJo software and connectivity, and then managing your reagent inventory. I'll just take a quick sip of water. All right, I'm back. Okay, so for the live demo, excuse me, I still have a bit of a cough. Okay, so we're here at bdresearchcloud.com and then sign in with your FlowJo portal ID. So you just type those in and press sign in. If you don't have a portal ID, you just go to create account, put in your email, press sign up and follow the instructions. But I have an account, so I will just go to sign in. So the very first time you log in, it will show up like this, your name and your individual org. And this is for you, and you cannot invite anyone to it, but you can still do everything you want to. You can create experiments, panels, anything you want. But if you want to create one from your lab, I'll show you how to do that. Only one of you needs to do this. So let's say I want to create a BDRC organization for my lab. Once I've created my individual organization, I would come and click my name, go down to create an organization. So I would click here. And then I see the different license types of BD Research Cloud. Here's the individual one that's created automatically when I first sign up. It is completely free, and same with the essentials one that we're going to set up for the lab. So here I can invite up to 10 of my coworkers to join BDRC for free, and I get a little bit more data storage capacity for each user as well. And I have some collaborative features that are enabled in the essentials license type that's not there for the individual one. If I want access to more seats than 10, I can upgrade to either professional or premium license type. These are paid license types, and it gives you access to greater features like the instrument monitoring. That's a professional feature. And then the reagent inventories, that's in the premium. But in the essentials, you can still do a lot of things. You can upload and share your cytometers, create panels, create FACSDiva experiments. So that's what I will show today. So to create in essentials, you would just press this create free org, put the name of your lab or of your core lab, fill in the information here and press submit. So by pressing submit, it will then become available here in the dropdown. So you'll have your individual organization and then the new one that you just created. So I'll just call this My Lab. You can choose to pin this organization, so it makes it your default. So next time that you log in, it will default log you into the My Lab BDRC organization. So if we first go to groups and projects, well, actually before that, this is the login page. You can see large tiles of the different sections. You can click directly on any of the tiles to go to that section, or you can click on the tabs at the very top. Those bring you to the same places and they should match. So panels, experiments, and so on. The very first time you log in, you have a tutorial video that gives you a little tour of BDRC. I recommend you watch that. And every page that you go to in BDRC will have different tutorial content. So the first time you go to these different places, the tutorial will pop up. If you don't want to see these anymore, just disable the tutorials, press OK. They won't pop up anymore automatically. Just know that if you need more information about any page that you're on, you just click this little tutorial and it'll provide additional content there as well. While we're down here, there's tech support button that I can click. So if you need a bit more help, these are the videos from FlowJo University. You can click there, it'll bring you to that site. Frequently asked questions. And if you have any suggestions to make, feel free to contact me here as well. Okay, so if we go to groups and projects, I can either click here or click here. The first time you log in, you won't have any groups here. You'll just have to create, oh, I believe you'll have a default group called group 1. So if you want to rename that group, you can just press the edit button here. So you can rename the group to whatever you want it. You can call it common, general, whatever you like, or whatever other structure you have. So this is how you create a group. And then within the group, you can choose to create one or more projects. So you'll have a default project within your group. So I think it's group one and then project one within that. So you can choose to create additional projects within your groups here. Once you've created those groups, you can invite your lab mates to join this organization. So you go to users and you press the invite button. So here you would just put the name of your user you want to invite, press add. You can add multiple people here. So let's say I want to add 2 people. I don't know if it'll let me. Oh, there we go. So you can add more than one email address, and then you can add them to one or more groups. So that's what you can do. And then here is you set permissions for those users. So if you want different permissions for different users, you'll have to do separate invitations. But if you want to give everyone the same permissions, then you can invite them all at once. I like to just make everybody a co-admin, give them permission to do everything. But if I don't want that, then I can always, select what I don't want them to be allowed to do. Then you just press invite and it will send them an invitation to join BDRC. So they don't already have to have an account. You can invite them and then they'll get sent by email instructions on how to create a BDRC account. So now that you've created groups and projects, you've invited users to one or more groups, we can jump into a cytometer. So if you click over to the cytometer section, this is where you can add or connect to a cytometer. So to do so, you would just press the add button in the upper right, click add, and there's different ways to add cytometers. If you have a cytometer that has BD FACSDiva on it, we recommend this first option where you would upload the configuration file. We recommend this to ensure that when you do create a FACSDiva experiment, there's compatibility between the experiment you're creating in BDRC and your cytometer. So this ensures that your detector name matches perfectly. So that's the option that we recommend if you have a FACSDiva experiment instrument. If you have a different instrument, we would recommend you create a custom cytometer. So here you could just write the name of your cytometer, the vendor, the model, configuration name. You would give it a lab location. So if this isn't populated, you just add a new lab location. And then you can add the lasers and detectors manually. You would just fill in this information for your cytometer and then save it. The last option, within this option, you can either manually enter all of this information or you can use another cytometer as a base. So let's say here I can look up other cytometers, use them as a base. Select here, for example, it'll pre-populate its configuration. And if yours is just slightly different, you just go in and edit and change those parameter names or laser and detector information. You can do that here. So first option is importing a file from FACSDiva. The other one, you can either create it manually from scratch or use another one as base. The last option here is add a public cytometer. So let's say you don't have your own cytometer, you want to connect to a core lab cytometer. I will pretend I work at the Hutch. So I will look up Fred Hutch, and then I get to see which different buildings there are and which cytometers that core lab has already uploaded. So let's say I want to run a create a panel for the FACSDiscover. I can click on it and press link cytometer. So by doing that, it will add that cytometer to my BDRC organization. So Fred Hutch, here's the essay that I just added. The little public tab lets me know that I'm connected to someone else's cytometer. So if I click on it, I see its configuration, but I cannot modify it. However, if it doesn't have that little public tab, this is a cytometer that I've added myself, and I can always edit this if I need to. Any questions about how to add or connect to a cytometer? Okay, so far so good. So once you've created or added a cytometer to BDRC, you can create a panel for it. So let's go ahead. Actually, let's go through population first, and then I'll go to panels. So within population, this is where you can add specific markers and antigen density to define cell subsets. BDRC comes preloaded with literature-defined population. So for example, if I click here on this B cell CD19, it gives me a generic definition of what a B cell is. It's a CD3 negative, CD19 positive, and it gives me a link to the citation where that definition came from. So these are just generic definitions of cells. You can also create your own based on what you're studying in your lab. So for example, here I created this EJ Treg2 population where I assigned a CD3 marker and some antigen densities values. So it's negative for CD127, it's low for FOXP3, and then you can see CD3, CD4. So to create a custom population, I would just hit this create up top. And so let's see, let's create EJT reg 4 just for fun. So target species, human. I can add markers from another population that already exists, or I can just come and create them here one at a time. So let's say CD3, and then how much CD3 is there? I'm going to say it's mid CD3. Whoops, CD4. So let's say it's high for CD4, it's negative for CD8. And you only have to do this once. If you're always using these definitions in your panels, then the population feature is quite nice. So let's go with FOXP3. And we'll just say it is hello for FOXP3 and CD127. Let's say it's negative. Okay, so once I've made this definition, I can submit it, and then it will create this additional EJT rig 4 over here that I can use during panel design. So let's hop over to panels. So I can click up here at the top, or again, from the home page, I can click on panels. So just to get you oriented in this panels section, you have custom panels. If this is a new org, this is blank because you haven't created any new panels yet. But you also have access to published panels. So these are all the OMIP. So for example, OMIP 102, I can click on it, see what the panel contains, which cytometer it was used to develop, and then visualization tools. You can see the spectrum viewer of that, whoops, of that particular panel. So I can view the spectral graph, the similarity matrix, the BD hotspot matrix of that panel. And then up top is the spectrum viewer. You can view the spectral graph, or you can choose to look at other views, the combined, where you can click on each laser line one at a time, or the stacked view, where you can see each laser line individually, the complexity score, all that fun stuff. So that was the published panel. Same with BD defined. So these are BD panels. Let's say if I click on any one of these, I'll see the content of that panel, a link to the citation from that panel. So it'll bring you back to the interactive human cell map. So which one was this? The 3 laser T cell. Oh, was it the B cell? So yeah, you can see details of it, some gating information from that reference. And again, the cytometer is optimized with, and then visualization tools. If you're curious to know if there's a published panel, an OMIP, or a BD panel that might suit your need, but you're unsure and you don't want to click through them all individually, you can do a search. So if you go to all, you can start filtering, say, okay, which one of these panels has FOXP3 in it? And it'll restrict the list and only show you panels that has FOXP3 in it. What about those that also have 56? Let's say I'm interested in K cells. Oh, look, only one panel has both FOXP3 and 56 in it, and that's OMIP 80. So that's a quick way to look through many panels all at once to find what you're looking for. So if, for example, in this case, I'm interested in OMIP 80, I might choose to use this panel as base. And then I can change which cytometer and choose one of my cytometers that I have access to see how well this panel works for my cytometer. And I can then modify it as needed. Okay, but let's go ahead and create a panel from scratch. I'm going to pause real quick in case there are any questions. Doesn't look like it. Okay, let's proceed with creating a panel from scratch. So that would be pressing this button below your name in the upper right corner, create panel. Create panel, give it a name, assign it to a project. And I can either use another one as a base or create from new. So I'm going to create a new panel, press start. So there's 5 steps. Step 1 is to select which cytometer you want to build this panel for. So let's go ahead. I'm going to select an S8. Lots of S8s. I'm just going to choose a default configuration for S8. Good more. There we go. So this is the S8 that I want to create it for. If I want to double check that's the correct one, I can expand. So collapse, whoops, the laser or expand it. Once I expand it, I can then see the details of that cytometer and make sure that's the one I want to build the panel for. Oh, there's a question about the hotspot. I'm just going to go through these next 2 steps and then I'll show you how the hotspot works. So step 1 is selecting the cytometer. And then step 2 is selecting your markers. So here I'm going to build a human panel, and I can either choose to use to enter the markers individually, and then it'll populate the list, or like I just showed you, I can pre-create common sets of markers that identify the cells of interest for my lab, and then it adds them all at once. It adds the antigen density information. I can choose to delete this default population here. So that's one way to add multiple markers all at once. So let's say I'm also interested in B cells. I'm going to add B cells here, and it will add those markers. So CD3, 19. I'm also interested, say, in CD20. I can add those individually. Let's say I have a marker that I search here and doesn't show up. So tetramer, Emilie. So if I search for it, I already created. So tetramer EJ. So tetramer EJ does not exist. So didn't find a match, add a custom reagent. So you're not limited to the BD catalog. You can create custom reagents. So let's say I'm going to say add custom reagent, target species, human, tetramer Emilie, or EJ. No results found. That's okay. I'm going to create it for that. Select a brand. I'm going to say it's a new brand, custom or in-house brand. And then here I'm going to select which fluorochromes I conjugated it to. So let's say I made it in FITC, in PE, and in BV421. Then I'm going to say add 3 reagents. So now it creates them in my custom reagents section. So then if I, tetramer EJ. There it is. So now I can select it, add it to my panel, and move on. There's many options in this section. You can, if you have specific clones that you want to only build in those specific clones, you can pre-select them or you can leave them blank. You can, if you want to use put more than one marker in the same fluorochrome for exclusion purposes, you can do that. So a dump channel. In this case, let's go ahead and put CD19 and 20 together in a dump channel on the same fluorochrome. What else? I can do a viability dye. And because this is the S8, I have an additional column here for imaging. So I'm going to say I can pick up to 3 imaging parameters. So CD3, CD4, and CD8, I'll put in my imaging channels. I'm going to go a little bit faster because I see we're getting at time. So this was step 2, where you can add or define your markers for your panel. So step 3, this is where the fun happens. I will get you oriented. In the upper left is the spectrum viewer. So because I chose a spectral instrument, the spectral signature graph shows up. Below it, you'll have your populations table that shows you the antigen density of one or more of your cell population. So you can add as many populations here as you want and define them with your antigen density markers. You'll have similarity matrix, hotspot matrix. These will become accessible once I start assigning fluorochromes. In the middle here is the list of your antigens. So because I'm making an imaging panel, these have been separated by either imaging markers, non-imaging markers, and then the exclusion markers that I'm putting together on the same fluorochrome. The density here shows me the fluorochrome density, and because I have more than one population, it's showing me V for variable, but if I want to look at any one of these, I can click on the density here. It's going to show the EJT reg density, or click again, it'll show me B cell antigen density, and I can sort on these densities. For example, instead of sorting the markers by antigen name, I can sort them by antigen density. So within each section, it'll sort these by antigen density or by fluorochrome availability. And these, I can sort the order high to low, low to high. And then it'll show me that here CD8 comes in the fewest amount of colors, CD3 comes in the most amount of colors. Same here, and this is per section. So tetramer EJ will come in the fewest amount of colors, L27 will come in the most amount of colors. So for example, if I click on CD8 and I want to know which fluorochrome I should assign it to for my panel, I can click on the fluorochromes individually to see its spectral signature. These are imaging markers, so I'm actually going to change it to the combined view and select the imaging. So here, these are my 3 imaging filters, and I want to know which one of these fluorochromes is best for the imaging filters. So you can make your decisions based on antigen density, fluorochrome brightness, but I'm going to go ahead and select this RB here and select. Oh, so once you like a fluorochrome that you have clicked on, you just press pair, and then it'll move that. It'll take that marker away from this list and bring it to the top as paired. So CD4, BB515, sure, why not? So I'm going to click pair. It moves it to the top here. And as I'm pairing things, I might see some warnings, right? So these red boxes, if I hover over the box, it'll tell me what that warning is. So AmCyan uses the same peak filter as BB515, and they're not recommended to be used together. So if I click on it, I can see, oh yes, they're in the same filter. It's not very bright. If I don't want to see fluorochromes that have any warnings, I can remove those. So hide conflicting fluors. And then these are showing me paired, so exact matches to what's above. If I don't want to see those either, I can say hide those. So what I'm left with are just better choices. So I'm going to just click here. Okay, BB700, fun, pair. So now that I've started pairing things, the similarity matrix and the BD hotspot matrix have started to populate. So I can click on those and see the effect. So the question was, how does the hotspot work? Can you elaborate? So the hotspot, if you do want more information about the hotspot, remember that the tutorial, the content of each tutorial is specific to the page that you're on. So if I click on the tutorial here, I will learn more about how to best select fluorochrome. So there's concepts about panel design. There's also a link here that will bring you to the BD website, talking again about best concepts, things to consider while designing your panel, short little videos to help you along. And then if you scroll to the bottom, then it shows you more details about the hotspot. So without reading all of this, briefly, the hotspot matrix predicts unmixing dependent spread in the context of a specific how to read it. So how to read a hotspot matrix. First, you look at the diagonal entry. Each diagonal entry corresponds to a single fluorochrome. A value of 1 indicates no unmixing dependent spread. So far we have no spread or very little, which is fantastic. A diagonal value greater than 1 represents the factor by which unmixing dependent spread would amplify the noise. So if you have a value of 2, then you're going to spread a factor of 2 from unmixing. So let's say, for example, I intentionally pick something not great. So I did pick BB515 here. Oh, and let's hide conflicting floors. So by hiding, I took away choices that aren't great. But let's say if I leave those, and for tetramer, I choose FITSI. Now you can see when I clicked on FITSI, I got a value of 5 here. And this is telling me that FITSI and BB515 in the context of this specific panel will lead to a 5-fold spread of both BB515 and FITSI. So these two together in this panel will lead directly to unmixing dependent spread. If I go to similarity matrix here, it also shows me that FITSI and BB515 have a similarity of 0.98. They are related but different. So similarity matrix and hotspot matrix are related, that if you have highly similar fluorochromes, they will likely lead to unmixing dependent spread, but not always. So this is one value and BD hotspot matrix is another. So here, if I pick BB421, oh, much better choice, right? So the hotspot lets me know before I even start making decisions which pairs are better. So viability dye, I'm going to, again, remove conflicting floors. Now that I'm in my non-imaging markers, I get a blue box. And if I hover over that, it says PI will be detected in one or more imaging channels. So this is letting me know that this might conflict or affect the quality of my images. So if I don't want those as well, I can remove all of them. So let's go ahead and, so yeah, I can click on the different fluorochromes, see how they affect my unmixing dependent spread. If these are all still values of 1, then I'm in a good place. And then I can put this back to spectral signature graph, so see where my areas are. So this one's kind of close to that one. I can choose to spread it out if I wanted to. Don't have much in the UV. Let's put something in the UV. All right. So here you can see the exclusion channel puts both of these markers together. Then I can assign a fluorochrome that is good for them together. And then the last ones here. I'm just making random choices, not thinking about it too hard at this point, just for the sake of time. All right. Whoops. Okay, so now that I've done pairing all the fluorochromes, if I want to remove from view any one of these, I can choose the little eye icon. So I'm not unpairing them. I'm leaving the panel as is. This is just to take a closer look at certain spectral signatures. I can also go back to my populations table. And if I want to identify the spectral signature of a specific population, I can click on this population and it will use the antigen density information. What this will do by clicking the eye icon, it removes the spectra of anything that's negative for this population. So what I'm left with is anything that is likely or possibly co-expressed on this population. And then I can look more closely to see, oh, are these good fluorochrome choices to be co-expressed on a population of cells? And then I can look at my next one and it'll show me which fluorochromes are likely to co-express. If I don't know, it'll show me yes, but it'll remove anything that's negative for that population. Then I can evaluate each population individually to assess the fluorochrome choices. Hopefully that answered your hotspot question. We just have a few minutes left, so I'll just wrap this up. Once you're done assigning your fluorochromes, you complete the step. At this point, you're done assigning Fluorochromes to markers, what you just have to decide is which clone you want to move forward with. So for this particular fluorochrome, if you click on the variant, it shows you your options of different clones and different test sizes with the list price to give you a relative idea of how much these cost. So you can make different choices here. And then once you're done this step, this is finalizing your shopping list. So if you have any of these already in the lab, you can remove them. You don't need to buy them. You just need to buy the remaining ones. If you accidentally took away something, you can add it back. And then you can finalize your workflow. So here you can transfer your reagents to the cart. You can open a shopping list. You can download either the full panel or just the shopping list. You can email the shopping list to your purchasing person if you're in an academic setting. You can request a quote by pressing this button. It'll automatically send an email to your local rep. And then if you're done, you can view your panel. So by clicking View Panel, it brings you back to this panel homepage. This is the panel we just created. By clicking on the panel, it brings you to the details of that panel. So here you can see the details, which cytometer was created on. It brings you back to your visualizations, your hotspot matrix. So here, these are all values close to 1. Then here, your staining sheet. So if these reagents were in my inventory, I can then update them and add titration information. And when I come here to staining sheet, this titer information would be pre-populated, and then I can create different staining steps. So by creating a staining step, I would then be able to drag and drop which reagents I want in which staining step, and be able to then move along with staining cells. I'm going to pause here. We have 3 minutes left. I just want to make sure I address any questions there might be. So there's many more that we didn't cover in depth in the live demo. So in the experiments, this is where you would create a FACSDiva experiment. Workflows, you can create custom workflows. These could be either experimental workflows where you're keeping track of staining, or they can be cytometer maintenance workflows. They're fully customizable. The great part about BDRC is that you don't have to buy into the whole system. You can pick and choose what's useful for you. If you only want to use it for panel design, great. If you want to use it for speeding up time for your Diva experiment creation, you can use it just for that. You can use it for your, just for data. Some people use it just for the period where you're performing analysis on the data. So you would upload your data to BDRC, perform your analysis in FlowJo, and then when you're done, you can move the data away to your normal data storage. You know, if you have institutional data storage, you can do that. You don't have to buy into the whole system all at once, all or nothing. So just use it for what's useful for you. Again, I'll reiterate, if you want a more in-depth demo, or if you want me to help you set up your lab and actually walk you through how to do certain things, I'm more than happy to do that. Yeah, I'll just leave it at that. Thank you very much for joining today. I hope this was informative. Again, the resources for the tutorials, you go to flowjo.com, learn webinar. And if you want to watch this again, just go to the recorded webinar, and that's where you'll find it. Great. Thank you. Hope you have a wonderful day.